Hi everyone, welcome to the channel. In this video I am going to talk about very interesting topic pointer, which is widely used in C or C++ programming. Here we are going to see different flavors of these pointers, like what is double pointer, which is also called pointer to another pointer. We'll talk about what is null pointer and what is the use case of this null pointer. Why do we use it? Next we'll see what is void pointer. These are different flavors that we use in our programming and where is it used. And lastly we'll talk about pointer to constant and what is constant pointer. So these topics we are going to cover. One more topic I forgot to mention here, the concept of reference. Sometimes it looks similar to the pointer, but it is totally different concept. We'll understand this one in detail. Let's proceed with basic concept of this pointer. Pointer is basically a normal variable. It's not something different. It is a normal pointer which contains some value, and what it contains, that only it differs here. It differs with the normal variables. It contains the address of another variable. Let's say this is your integer variable. You have taken this integer variable whose address, let's say 1000. So this pointer will contain the address of this variable. What is the address of this variable? It is 1000. And how do you take in programming? You must be knowing this, but I am just repeating here. Let's say you are having an integer variable and you want to set the value of this to, let's say 10. So now this memory location is having value of 10 and you want to take a pointer. And what will be the type of this pointer? It must be integer pointer. You can't take anything else. You can't take character pointer or short pointer or anything. You must have to take same data type. So this pointer will contain the address of this integer variable, right? And how do we take the address of this variable? With the help of this ampersand symbol. So now this pointer PTR is pointing or referencing to this integer variable called var. Just one step further, let's say you have taken this array which is having two elements. And what is the size of this array? This is size of integer, which will contain 4 bytes, right? Your first element will contain 4 bytes. So your lower memory will be having 1 and next 3 will be 0, right? This is A0, 0th element. Then next 4 bytes will be first element, right? A of 1, which will contain 2. And let's suppose this is your address 100 and this is 104. And you are pointing this array with the help of this integer pointer PTR. So here I have assigned 0th element of this array, right? 0th element, this is same as this. Both will give address 100, which is pointed by this PTR. So let's suppose I am doing an addition operation here. PTR equals to PTR plus 1. So now what will be the value of this PTR after this line? Once I execute this line, so what will be the value of this? This will not be 101. This will be 104 because we have taken its data type as integer. So this will contain 104. So if somebody asks you to calculate the size of any variable, so you can simply take a pointer, any pointer, and with the help of that pointer you can calculate the size. What you have to do, you need to just write this code. And why do we need typecasting here? That is again a question here. You might be confused of this. Why do we use this typecasting? Okay, this is a basic question that you can have. This question is asked many times in interviews. Write a program without using size of operator. The size of operator, what it gives? It gives the size of any variables. So you don't have to use this size of operator and they will ask you to write a program to just calculate the size of any variable. So you can take the help of this pointer concept like this. This will give you the result. And let's understand why do we need this typecasting here. Let's suppose we are calculating the size without using typecasting. So what will happen? So I'm just writing here PTR plus 1 minus PTR. So if we write this, so how it will be interpreted? Since this PTR is now pointing to 100. So it will be 100 plus 1 minus this pointer is 100, right? So it will give you 1. It is not going to give you 4. So when you do typecasting here, I'm just typecasting to character pointer PTR plus 1. So now this one will be typecasted. They are changing it to PTR plus 1. Means now it is 104 because we have used typecasting here. And what is it expecting here? It is expecting some pointer, not a value. You don't think it will come 101. It will not come. It needs a pointer, right? So now your complete thing, this complete thing will give you the value of 104. You can try this. This will give you 104 and when you subtract it with 100, so you will get the value of 4. That's what you were expecting. With the same concept, you can calculate the size of any union, or you can calculate the size of any user defined data type also, a structure or any other data type, int, long, short, anything. The next question, why do we need this pointer itself? What is the requirement of it? Since we have a normal variable, right? Normal variable where we have and we can play with this. Then why do we need this pointer? Pointer concept was introduced, but let's understand the reason behind it. Let's suppose you are having an array whose size is very big, let's say 1 lakh. And you want to iterate over it. So writing with indexes, it is very tedious job for a programmer or for a reader also. They can miss something, right? If they miss even a single element there, right? So it will be a bigger risk for the complete program, right? So for that reason, what we do, we take a pointer ptr and let this pointer ptr point to this array A. So we have written like int star ptr equals to A. So now it is pointing to this array, and simply by moving over this pointer, if we do ptr++, so it will jump from 100 to 104, then 108, 112 location and so on. So by just moving this pointer, you can iterate over the whole array. So with the help of this simple concept of pointer, you can avoid writing indexes and all. So that's where it helps you to write a very efficient code, right? And it will be a purely error-free code that you can write with this. And another use case is, with the help of this, you can pass a reference here. When you call the swap function from your main with, let's say, address of x and y, and let's suppose this address of x and y is 100 and 104. So now this pointer A will point to this address 100 and pointer B will point to this address 104, and it will directly access these memories. It will not create a separate memory for this and will access the same memory here, and it can update the value over there. Suppose it was 5, so from 5 it can change it to 10, 15, anything. And if you call here, let's say with x equals to 1, y equals to 2, so after executing these 3 lines, your x will be changed to 2 and y will be changed to 1. Right? So this way of accessing or updating the memory location with the help of these pointers is called dereferencing. What is it called? Dereferencing means we are dereferencing or accessing the memory location with the help of these pointers. When this pointer is pointing to this variable, this is called referencing. And just reverse of it, when we access the memory location, means we want to read the value what is present here, or we want to update this value. Let's say we want to update this value to 5, 10. So basically the accessing the memory with the help of this pointer is called dereferencing, right? So this is just, so these two are very basic concept here, referencing and dereferencing. And many times it is asked in interviews, right? So always give the simple answers. It's not complicated. Next, understand what is double pointer, right? This double pointer is also called pointer to another pointer, pointer to pointer. So here with the help of this pointer, we can point to another pointer. Let's say you are having an integer variable where which you are pointing with the help of this pointer ptr. This pointer is having the address of this integer variable, and then you have taken another pointer which is storing the address of this pointer itself. So now let's say this is your variable which is stored at 1000, which is pointed by pointer ptr. So now this will contain 1000 and its address is, let's say, 2000, and you have taken this double pointer ptr1 which is pointing to this pointer, not this one, right? Not this one. And this will contain the address of this pointer which is 2000. So this is called pointer to pointer or double pointer. Next, understand what is null pointer and why do we use it. Null pointer is simple concept, and it is always advised to initialize your pointer with null pointer. Means just assign it to null. And why is it advised so? So suppose you have not initialized it, you have simply taken this pointer and kept it floating, and let's suppose you are going to dereference it, trying to access or change that memory. Let's say you are writing 100 over that. So when you do that, so you are not sure what is the address of this pointer. This pointer is there, right? So do you know the address of this pointer? No, right? It could be something 0, 1 lakh or anything. So when you don't initialize it and kept it floating, and the time you are trying to access it or trying to update this memory location by dereferencing it, and let's suppose this pointer which is uninitialized is pointing to some very critical locations where let's say your OS is sitting, or any hidden partition manager, any critical section, if you try to access here which is uninitialized, so it can access, right? It can point to those locations. So in this case you will try to change the value over there, which can lead to OS crash or complete system crash it can cause. So to avoid those scenario, it is always advisable to initialize your pointer with the null. So basically this pointer will be pointing to nothing. Its value will be 0, so it's pointing to nothing. And it will give you an error if you try to dereference or update with the help of this. So first you need to point to some variable, where or something, after this line when you have initialized with null. So after this line you can initialize with any other variable address, not variable, ampersand you have to use. Then you can do dereferencing for it. So this was the simple concept of null pointer. And now let's understand another flavor of it, void pointer. So this void pointer can point to any type of variable. Let's say you are having integer variable I, you are having another variable whose data type is character, let's say C, and you have taken a void pointer ptr and you have assigned with address of I, which is integer data type. And in the same way you can also point to this character pointer with the help of the same pointer which is type of void. This is a void pointer. With the same void pointer you can point to both your integer variable as well as your character variable. But here if you try to dereference here with the help of the void pointer and you write like *ptr, right? That's how you dereference and you try to access it. So it is going to give you error, even though you have assigned the address of this integer variable, but the data type of this pointer is still void. So for dereferencing you must use or typecast first. You need to typecast to any kind of data type first, and after that only you can do dereferencing. So this is how you can do dereferencing for the void pointer, and this is mainly used in dynamic memory allocation. In dynamic memory allocation we use malloc and calloc, right? But we use malloc and calloc. So with the help of these two, we can allocate memory dynamically in C or C++. And what it returns? Both returns void pointer, right? So before using it, we must need to typecast it. And how do we do that? It is very simple. Let's say you have called malloc and where you want to allocate 24 bytes. And this is going to return you void pointer. So you must typecast it into some data type. So here I have just typecasted to integer. You can typecast to character, sort, or anything as per your requirement. If you have taken, let's say, integer pointer ptr, then you just typecast to integer pointer and allocate to ptr. That's it. And if you have taken character pointer, let's say C, so just allocate this to pointer C. Similarly you can do for sort. So whatever data type you want, you just typecast to that. And same scenario for calloc as well, right? So for malloc and calloc we often use this concept of void pointer, and we do typecasting before using it. Now I'll talk about one beautiful concept of reference. So what it is and how it is different from normal pointer. They look similar but they are totally different. These two are different. Referencing means it's just another name. Let's say you are having an integer variable A and you have re-referenced, or you are giving another name to this variable A. So this is basically aliasing. B is alias name of A, another name of A. This is not a pointer or something. This is not a pointer. Never say that this is a pointer. No, this is another name itself, and which is used for pass by reference. This pass by reference is different from call by reference. Call by reference and pass by reference are different. For pass by reference, we take the input like this. If you pass, let's say, swap x and y, you don't have to pass address here. In call by reference, we pass like %x and %y because we have to pass by its address, call by its address. But here just we are passing like this, means we are passing the reference here. So this A is the another name. Both will be pointing to same memory location. Your X and A and this Y and B will be pointing to same memory location. So if you just print the address here inside it, let's say you are printing the address of A here and address of B. So this will be same as the address of X and address of this Y. So if you are updating the value here, temp A you have written here, to swap it we use like this, right? And you are updating with B and B equals to temp. So these two values will be swapped, right? This is X and this is Y. So now it will be interchanged. This will be, if it was 1 and it was 2, so now it will contain 2 and this will contain 1 because we have changed this values here. Just a simple note for this referencing. Here you always need to assign in single line, right? You always need to assign in single line. If you write like this int A and then you try to assign it here, so this is a wrong way and it will give you an error. Here itself it will give you error. You always need to assign in one line. And here reassignment is also not possible because you have given another name, means upnam. Rinku, tinku, you give upnam, right? Alias means upnam. So here A is the upnam of X. So till now we have learned pointer concept. We understood why to use it. We use it for array or call by reference. Next we understood what is double pointer, right? Double pointer we understood. Then we saw what is null pointer, what is void pointer. Null pointer we use to initialize any pointer which is advisable. And why is it so? To avoid the accessing random memories or any critical memory. So to avoid that we use null pointer to initialize it with. Void pointer, it is used in dynamic memory allocation for malloc and calloc, right? And then we saw reference, right? Reference we saw. Now let's see the last topic. What is pointer to constant and constant pointer? First let's see pointer to constant. So this is a pointer PTR, let's say, which is pointing to some constant variables. This variable is constant. You can't change the value over here. Let's say its value was 5. So you can't change it to 10, 15 or something. This is not possible. And this pointer is pointing to this constant variable. That's it. This is a very basic concept. This was address of 1000. So it will contain the value 1000 and it is pointing to this memory location. And how do we write it? Yeah, it is very simple. Int const or constant. In any way you can write int const or constant. In place of integer you can take another data, right? Character or anything that is purely true, and then you just take pointer for this. So that's how we use pointer to constant. And next concept is just ulta of it, constant pointer. Constant pointer. So what it is? Yeah, this pointer itself, this PTR, it's a constant pointer. Suppose you are pointing to this variable var whose address is 1000. So this pointer will contain 1000 whose address is 2000. So here you can't change the value inside this pointer. The value inside the pointer is constant, which is pointing to this memory location 1000. You can't make it to 2000, 3000 or something. This is not possible. And how do you write here? Yeah, it is int or char anything, asterisk key operator you have to use, and then you have to write const. So now your pointer is constant, not the variable. This variable is not constant. This can change to anything. This can change to 5. This is possible. This can be 10, 15. This is possible. But changing here is not possible. You can't change the address inside it. Address at memory location 2000, you can't change it. This var. If you have done like this var, so you can't change address here. It will be always pointing to this variable var. Here I tried to capture as many things as possible. I hope you had understood all the concept. If you have still any doubt regarding any topic, let me know in the comment box. I'll try to explain those. Thank you so much for watching this video. Stay tuned and I'll see you soon.